This is a neat lesson. I've been wrong before, so we'll just leave that alone. But I think this one's cool. A couple of concepts that we want to get kind of thought out before we get started with taking the notes. I want you to remember a couple of things. One, log base b of 1 is what? Base to what power would give me 1? 0. Base to any base to the power of 0 gives 1. Okay, so the reason that this is the answer is because b to the 0 power is always 1. Bless you. Doesn't matter what the base is. That's true. Okay, so anytime you see log base b of 1, you know, answer is automatic 0. Every time. Another thought is that log base b of b is something. And so the question is, b to what power gives me b? B to what power gives me itself? 1. So b to the first power is b. Okay, so this is why this works. B to the first power is b. So b to 1 gives me the argument. Are we understanding that? Yeah. Okay. So if I have log base 5 of 1, the answer is 0. And if I have log base 5 of 5, the answer is 1. Okay. So we can handle that. That's not a problem. What if I saw the natural log of 1? What's the answer to that? This is natural log, by the way. 0. Yeah, natural log of 1 is 0. Why? Because this is log base e of 1. Remember that the natural log is just a log in base e. So far, so good? What is the natural log of e? 1. Good. Because again, log base e of itself is 1. So far, did these rules make sense? Okay, so these are really common rules. Another rule that you should know is if you have log base b of b to the x power. Log base b of b to the x. Your answer is x. Why is that? Because what we're saying here is b to something gives me b to the x. Well, what's your something then? X, right? Your something has to be x or they're not equal. Does that make sense? Okay. That's really helpful a lot if we have something like log of 100.
I'm sorry, but can you go back to the other rules? I didn't get the last two.
Yep. I told you, I'm very excited about this lesson. I like it. Okay, so this is log of 100. There's a couple of ways of looking at this. You could ask yourself, 10 to what power gives me 100? And you would see your answer is, oh gosh, that was slow. 2, right? 10 to what power gives me 100? 10 squared. How do I know it's 10? Because there's no base, and that means that the base is 10, right? I could look at it this way, or I could follow kind of this train of thought, and I could say, okay, this is going to be log base 10 of 10 squared, where 10 to what power gives me 10 squared, and now I realize the answer there is 2. So 2 different ways to look at the same type problem. Any questions on that at all? No? Okay. All right, we have one more property here. We understand that this only works if your bases are equal. What that means is that your powers are equal, right? So this is a property that I want you to write down. log base b of m equals log base b of n. So notice that your bases are equal here. Log base b of m equals log base b of n. This is only true if and only if, so that IFF, that's shorthand for if and only if. It's a math thing. We write IFF. This is only true if and only if what? The bases are equal. So this is a true statement if and only if m and n are equal, if your arguments are equal. Your bases are already equal. They're both b. So this only works if m equals n. Are you following that? So let's call it log base 6 of 3 equals log base 6 of x. What is x? 3. X has got to be 3. Yeah? Okay. Let's do log base 3 of 3x equals log base 3 of 2x plus 5. How would I solve for x? Set your arguments equal. Because why? How do I know my arguments can be equal? Because the base is the same. It's 3 on both sides. So can we solve for x here? What is x? X is 5. Kind of a cool concept. Any questions on that particular train of thought? No? Okay. The first property that we're going to learn today is called the product rule. This is the product rule for logarithms. And this really comes from exponential rules. We just do them backwards. Now that we're dealing with logarithms, we're inverting our exponentials. Okay, so the product rule for logarithms. Hello? Hello? Yes, I'll sit there. Bye. Autumn, you're signing out. So the product rule for logarithms goes like this. Log base b of m times n. So in your argument, you've got something being multiplied. The way that that expands is log base b of m plus log base b of n. So do you see up here the red rule that says if I multiply my bases, I add my powers? This is that. But it's kind of backwards because it's in logarithmic form. Okay? So what we're doing is we're just unpacking something. We're not solving here at all. In this lesson, we're just rewriting in a different expanded form. Okay? My daughter is named... I'm going to pause. Okay? We're unpacking it. It's not going to be different. It's just going to be expanded. Do you understand what I'm saying? Okay. So our first example here is going to be example 1. We've got to expand log base 3 of 30x times 3x plus 4. Log base 3 of 30x times 3x plus 4. And what you see here is a product of two terms. You see the 30x times the 3x plus 4. And so when we expand this, that's going to come out as log base 3 of 30x plus log base 3 of 3x plus 4. Okay? The 30x, inside here is a product of multiple numbers and letter. So we can expand that even further. What are factors of 30? 20 and, or 2 and 15? Okay, and what's in the 15?
3.
A 3 and a 5, and there's an x up there. So this could actually be log of 2 times log of 3 times. You see what I'm saying? Because this is a product, we could go full-blown first, middle, and last name with this logarithm. It's super enjoyable, right? We want to expand it all the way out. So log base 3 of 2 plus log base 3 of 3 plus log base 3 of 5 plus log base 3 of x, and then finally plus log base 3 of this other guy over here, 3x plus 4. And that seems like a whole lot, and it is. We're just unpacking it down to its finest, smallest point. Okay, first, middle, last, and your mother's maiden name on the end. One thing that I wanted to point out is we did not expand 3x plus 4 any further, because that's not a product. If it had been 3x times 4, you bet we'd have popped it all the way out, but it's not. Questions on that at all? You want to try it? The try it says expand log base b of 8k. Log base b of 8k. Did you get to here? Log base b of 8 plus log base b of k. Anybody go any further than that? Okay, what'd you have?
Log base b of 2 plus log base b of 2 plus log base b of 2 plus log base b of k.
Good. So the 8 has a triple, I guess, of 2's. Log base b of 2 plus log base b of k. That's yuck. Oh well. Are we okay with it? All right, the next rule that we're going to learn today is called the quotient rule for logarithms. The quotient rule for logarithms. What's a quotient? A fraction, something where we're dividing. So if on the multiply, the product rule, we added, then what do you think the quotient rule is going to entail? Subtracting. Yeah, so they're opposites. So the quotient rule says this: log base b of m divided by n is equal to log base b of m minus log base b of n. Okay. So our job here is to, I wanted to do one of these problems that they had in the book before the example. This is like a pre-example too. This says 2x squared plus 6x. Log of 2x squared plus 6x divided by 3x plus 9. And I wanted to do this one for you because it might save you some time. Sometimes it's beneficial to simplify the argument before you go to breaking it apart and expanding it. Sometimes you'll be able to whack at it a little bit and cancel some things instead of having to expand it fully and have 79 terms. Okay? So look at this argument. Do you see anything in the top that we could do to simplify 2x squared plus 6x? You could pull a 2x. Do y'all see that? So I could rewrite this as log of 2x. And when I pull the 2x, what's left? X plus 3, good. And on bottom, what could I pull? Pull a 3, and what's left? Okay. If this was rational, I'd have a hole at -3, right? Cancel buddies make holes. But this is not that. We can just simplify it. We can get rid of that piece. It goes off. So actually, we have log of 2x divided by 3. Log of 2x divided by 3. How do you feel? Now do the quotient rule. On top, we have a 2 and an x, and they're being multiplied. So you're going to have log of 2 plus log of x. On bottom, the 3 is being divided, so we're going to say minus log 3. What's the base? 10. Notice we did not waste time writing that. Now are you ready for example 2? So example 2 says, expand, that means stretch it out, first, middle, last name, log base 2 of 15x times x minus 1 divided by 3x plus 4 times 2 minus x. Okay, so I want to attack that 15x first. What are pieces of that 15x that are making that product? What you got in there? A 5 and a 3 and x. So we're going to have log base 2 of 5 plus log base 2 of 3 plus log base 2 of x. That handles the 15x. What's happening between the 15x and the x minus 1? They're multiplying, aren't they? So we can add log base 2 of x minus 1. I don't have to do anything to expand that particular argument because it's not a product. Then we divide by 3x plus 4. So we're going to say minus log base 2 of 3x plus 4. Again, not a product, so we can just stick that argument. And what's happening with the last argument? Is it being multiplied or divided? Both. But from the top, it's being divided. So since it's on the bottom, we subtract it. Minus log base 2 of 2 minus x. And so your whole answer is going to be log base 2 of 5 plus log base 2 of 3 plus log base 2 of x plus log base 2 of x minus 1 minus log base 2 of 3x plus 4 minus log base 2 of 2 minus x. Easy? You want to try it before we finish today? Here you go. Yes, you do. What time does the bell ring? In 4 minutes? Oh, you got this. Expand log base 3 of 7x squared plus 21x divided by 7x times x minus 1 times x minus 2. And I'll work mine up here, and you can work yours on your paper, and we won't talk. We'll just see if we end up at the same place. tomorrow we'll finish this lesson. So this would probably be titled 6.5 part 1. And then tomorrow we'll do 6.5 part 2. And then I've already published homework, but if you want to wait until after the lesson tomorrow, you'll be able to do all of it then.